Have you ever wondered if your dog understands what you're saying? Or how your little sister learned to talk before anyone taught her grammar rules? Large language models can generate mountains of fluent text, but do these systems really understand what they're talking about? Today we're going to explore how different minds learn language, if at all. Let's start with humans. Babies learn language through a combination of innate abilities and environmental exposure. From birth, human babies are equipped with the ability to learn any human language. We know that babies' brains can initially distinguish every sound used in human language. A baby in Accra can differentiate Mandarin tones, and a baby in Tokyo can distinguish the English from By their first birthday, however, the baby's brain prunes away any unused sounds, strengthening the sounds that appear in the languages they hear. With lots of language input from other humans and lots of interaction with caregivers, babies start to babble, say their first words, and form sentences. Eventually, humans learn to fluently speak and understand the language of their environment. But here's the really cool part of human language acquisition. Babies learn incredibly complex grammar rules from messy, incomplete examples. Nobody sat you down and explained subject-verb agreement. You just figured it out. Some researchers think we're born with specialized language circuitry, that evolution hardwired this capacity for language into our brains. Other researchers think we're just really good at pattern detection, using the same general learning abilities that we apply to learning music or learning faces. Most scientists today think it's probably both, some dedicated language learning mechanisms working alongside general cognitive abilities. Humans are remarkable language learners, but animal communication is amazing too. Dolphins have names for each other, prairie dogs describe predators in detail, and bees do a waggle dance to share flower locations. The question is, can animals learn human language? Well, it's complicated. For example, dogs probably learn commands through conditioning, by linking sounds to actions and rewards, rather than actually understanding abstract meaning. Your dog Peanut probably doesn't know that sit refers to the abstract concept of sitting. To explore whether animals can learn language in a deeper way, researchers turned to our closest relatives, non-human primates. In the 1970s, a baby chimpanzee named Nim Chimpsky was raised as a part of a human family. Nim acquired over 100 signs in American Sign Language and used them to make simple requests like banana eat or Nim play. However, he didn't invent new combinations or follow grammatical rules. He could express desires, but not any abstract ideas. Then came Kanzi, a bonobo who learned by observing lessons given to his mother. Kanzi understood thousands of spoken English words and even grasped some word order. For instance, he knew the difference between pour the Coke in the lemonade and pour the lemonade in the Coke. So some animals can learn word association like this hand sign means apple, and some can even understand some basic syntax like word order. That's really impressive, but it seems that no non-human animals have been able to learn the full complexity of human language, creating new words, mastering complex grammar, or imagining and talking about worlds that don't yet exist. Now let's talk about large language models, also known as LLMs, which are artificial intelligence systems trained to understand and generate human language. They learn language in a totally different way than humans. By age 3, you'd heard maybe tens of millions of words. In contrast, LLMs are trained on hundreds of billions of words, essentially the entire available internet. LLMs use mathematical operations called attention mechanisms that figure out which words predict other words. After processing trillions of combinations, they built internal maps of language structure. This is how LLMs learn grammar, context, and even social cues like sarcasm or politeness. If you've ever used chatbots like ChatGPT, Gemini, or Claude, you know that modern LLMs do a lot of things that seem to demonstrate understanding, like explaining metaphors and catching their own mistakes. But here's where it gets philosophically interesting. You learned the word hot by touching a stove. GPT learned hot by noticing it appears near temperature and coffee in text. It doesn't understand what heat feels like, so how can it know what hot means? Maybe a mind needs real sensory experience to truly understand language. And if that's the case, has an artificial system really learned language if it doesn't understand its outputs? Well, that's a huge topic of debate. So, how do different minds learn language? Humans start with a mix of innate ability and environmental exposure, picking up complex grammar rules without even really realizing it. Animals, while capable of rich communication, don't seem to grasp the full complexity of human language, especially when it comes to abstract ideas. And then there are machines, which process vast amounts of data and produce amazingly fluent speech, but they might not truly understand what they're saying. As we explore these different minds, human, animal, and artificial, one thing is clear. Language is more than just words. It's a window into how each system perceives, processes, and represents the world.